In this video, we're going to go over the dividing radicals exit slip that you took after the lesson. So this first one says simplify the following completely. So remember that we always want to never have a radical in the denominator. And right now we have a radical over this entire fraction. So when I have a radical over the entire fraction, the first thing I want to do is see if I can simplify the radical on the inside. Simplify the fraction on the inside. So if I have 8 over 32, that'll actually simplify because 8 and 32 are both divisible by 8. So if I divide 8 by 8, I get 1. And if I divide 32 by 8, I get 4. Now remember that when we have a big radical, I can always split it into two little radicals. So this is the same as the square root of 1 over the square root of 4. And the nice thing about 1 and 4 is they're actually both perfect squares. The square root of 1 is 1, and the square root of 4 is 2. Now you could have gone directly from this step to this step because technically 1/4 is a perfect square. It's 1/2. But also keep in mind that you can separate them if needed in case one of those numbers wasn't a perfect square. So the answer to number 1 would have been B. For number 2, we are going to have to rationalize the denominator because as we talked about number 1, we do not want any radicals in the denominator. So when I am trying to rationalize the denominator, my goal is to make the denominator no longer have a radical. So if I have square root of 5, I want to multiply by the square root of something, and whatever I multiply to the bottom, I have to multiply to the top. So I'm going to multiply by the square root of something in order to make my denominator a perfect square. Well, with square roots, I can always multiply by the same number because the square root of 5 times the square root of 5, well, that's going to be the square root of 25, which will ultimately become 5. So now I've rationalized my denominator and no longer has a radical. But keep in mind, whatever I do to the bottom, I have to do to the top. So if I multiply the bottom by square root of 5, I'm going to multiply the top by the square root of 5. Now, 4 is not a radical number, but 5 is a radical number. So I can't multiply them directly together. So I'm going to write it as 4 square root 5. So if 4 and 5 had a common factor, I would simplify this further, but I can't. So this would be my final answer. So therefore, the final answer would be C. The last problem is a little bit different. And this is actually one of the ones where we're going to use the conjugate, which was towards the end of the video. So I really hope that we watched all the way to the end because this is really, really, really important. So if you did not watch all the way to the end of the video, go back and watch the very end of the video because the conjugate is going to be super important for every math class from here on out. So when we're doing the conjugate, it's used a lot of times with imaginary numbers. That's how you'll use it in advanced algebra. But for right now, we're going to use it with radicals. So again, my goal is to get this radical out of the denominator, and I'm going to do that by multiplying by the conjugate of this. So the conjugate of this binomial is the same binomial, except for instead of subtraction, it's going to be addition. So I'm going to multiply the top and the bottom by square root of 3 plus 1. Because whatever I multiply the bottom by, I have to also multiply the top by. So the reason we do this is because the middle terms then are going to subtract. So if my denominator had been, let's say, square root of 3 plus 1, then this would have been square root of 3 minus 1, and you would have just switched it. So keep that in mind that it's always just the opposite of whatever your sign is. So I'm going to multiply the bottom out first. Now when I have the bottom, I have a binomial times a binomial, so I'm going to need to FOIL this out. So I have square root of 3 times square root of 3, which would be square root of 9. Square root of 3 times 1, which would be positive square root of 3. Negative 1 times square root of 3, which would be negative square root of 3. And then negative 1 times 1 should be minus 1. Now on the top, I just have a single number, so I'm just going to distribute that in. And I'll get 5 square root of 3 plus 5. Now, the reason we do the conjugate, which I talked about already a little bit, is because since I changed the sign, it causes these middle terms to subtract. And if you notice, square root of 9 is actually already a perfect square. So I'm just going to have 3 minus 1 left in my denominator after I multiply by the conjugate. And this should happen every time, assuming you switch the signs and did the conjugate correctly. In the top, those terms don't combine, so I'm just going to have 5 root 3 plus 5 So I'm going to have 5 root 3 plus 5 all over 2. Now let's say these 5s, kind of like with quadratic formula, if this number and this number and this number could simplify, then I'd have to go farther, but in this case it doesn't. So I can look at my answer choices, and the answer choice for this one would have been D. Let me know if you have any further questions on how to simplify with dividing radicals or the conjugate.